Hi everyone, this is Mary Niba here. In this lecture, we are going to see about linear search algorithm and its implementation using C++. Okay, we'll move on to the topic. First of all, what is searching? We are well familiar with this word, right? Since each and every day we thirst to search something new, right? Here also, searching means searching a particular element in an array. It has another name, sometimes called as sequential search, because here searching starts at the first element in the array and continues until either the item is found in the list or the entire list is searched. So it compares the particular number with all the element in the list. If the number is found, its index or location is returned. Else, unsuccessful command will be returned. Also note that the following sequential search does not require the list element to be in any particular order. That means, so it's not necessary to be sorted. That is, we need to be arranged either in ascending order or in descending order. So just consider this array. So this is a list of elements. So here it is having 7 elements. So just if I want to search number 27, so the what the algorithm says, so it first search with the first element, that is index 0 in the array, that is the number 35. So it search whether 27 is equal to 35. So it's not equal, right? So the it goes to the next element, that is index 1 or the second element, that is 12. Then again it's check whether 27 is equal to 12 or not. So it's not. Then again it jumps to the next element, that is the index number 2 or the array number 3. So it is equal. So it returns back the index. Sometimes if I want to search number 80, say 80, 80 is not in the list, right? So what happens means, so the compiler starts searching from the first element itself. So it search with 35, that is the 0th index. Then it search with 12, it's not there. Then it again search with 27, it's not equal. Then it again search with the number 18, then it's not equal. Then again it search with 45, then it's not equal. Then it's again search with 16, it's not equal to 80. Then again search with 38, it's not equal to 80. And finally it search with the index 7 also, there is no element, so it's not equal to 80 also. So it automatically runs the command, that unsuccessful search, so the element is not present in the list. So it is going and searching so many times, it search all the elements and then it finally stops, right? So this is the worst case complexity, because it has to search all the elements. So and this complexity is given by the order, worst case complexity as order of n. So now we'll let us see simple example. So to how to implement this algorithm. This algorithm is the simplest searching algorithm. So we'll see how to implement this using C++. So say I'm just going to take a compiler, online C++ compiler. So we are just going to implement this simple program here. So first, the first step is, so we have to get the, so we have to, before that we can declare the uh, data types or the variables. So we are just going to use a number, so which we want to search. Then we want just I, so what we are using, then an array. So I'm just taking an array of 100 size. So you can take any size, that's your wish. Okay, then you have to take the total number of, for storing the total number of elements in the array. So I'm taking n. Then cout, so I'm just entering, so enter the total elements in the array. First we have to enter the total elements slash n to get the output in the next line. Okay, so now we have to just get the data. So just I'm getting the total number of elements in the array as n here. Then you see, I have to ask the user to enter the elements. For example, if I am entering some 5 elements in the array, so the user has to enter all the 5 elements one by one. So we can ask the user, enter the elements, or they enter the numbers. So you can put /n to get in next line, okay, followed by semicolon. Yes, so we have to get the elements. So our array has more than one numbers and it can hold up to 100 elements in this program. So for getting that, we have to use a for loop. For I equal to, because I is already declared as integer, so for I equal to 0, I less than n, I plus plus. I plus plus, then you can put a brace or it's your wish. So Cn, so I'm just getting the array. Array is declared as A, so A of I. To get all the elements, we are using this. So then we can close the for loop. So for this can use for convenience. So just we got all the elements in the array. Got all the elements in the array. In the array. So the next step, so what you have to do means we have to use the logic. So before that, we have to get it from the user, that user which element he need to search. Here she needs to search. So enter the number to search /n semicolon. So this is a single number, so you can get it by and it is stored in number. Already we have declared this in as integers here. So no issues. Okay, then after this we have to use the logic. It's just a comparison. So again we can use a for loop for I equal to 0, I less than n, I less than n, I plus plus, open brace, if array A of I, if A of I equal to the number what we have to search. So if this is the case, so you can put it in a bracket. So if this is the case, so it has to be printed. So actually it should print or see out the number is present in index can give the size I plus 1. So it is in the index I plus 1. Right? Okay, you can close the brace or you can just give a break. If you want to come out of the loop, you can just close it. And then again, you have to search if the number is not there, what it has to display. If I is not equal to I is equal to n. That means if the I is equal to the total number of elements. Z out. So you can display something. The number is not present. The number is not present in the array. /n quotes semicolon enter. Then you can give return 0 for main function. You can close the main function. Okay, so now we can run the program. Yeah, it's executed and it's asking to enter the total number of elements in the array. So I'm entering some 5 elements. Then it asks to enter the elements. So I'm entering 1. It need not to be in a sorted order. You can enter any 5 elements. So I have entered some 5 elements. Then it will ask the element to search. So I'm giving 9. So it's in the fourth index. Okay. Right. So in this way, it's very simple algorithm. So just get the total number of elements. So they enter the number of elements, a number to search. Then we have to just compare. So but the complexity is more because the number is not present. It has to search from the first list to the last list. If there are 1,000 elements, it has to search from the first list to the last list. So that's a only issue here. Okay. Okay. Thank you for watching this video. Thank you.